Hello friends, in today's class we'll see the property of rational numbers. Now we will start with the property commutativity. For any two rational numbers a by b plus c by d is equals to c by d plus a by b. What it means is if we change the order of addition, the answer will be the same. This is what implies by the commutativity property of addition. We say addition is commutative for rational numbers. Now let us check with two rational numbers minus 3 by 8 plus 1 by 7. In that case, it is equals to 1 by 7 plus minus 3 by 8, which is equals to, we take the LCM 56, 7 goes in 56 8 times. So we get minus 21 plus 8 equals to minus 13 by 56. So this is how we find the answer. It is minus 13 by 56 even if we interchange the order of the rational numbers. Hence addition is commutative for rational numbers. Now let us take in the case of subtraction, let us take two numbers and let us find the answer. The LCM is 12. 3 goes in this 4 times, 4 2s are 8 minus 4 goes in this 12, 4 goes in this 3 times, it is 15, which is equals to minus 7 by 12. Now we will take it the other order. 4 goes in 12 3 times, it is 15 minus 8, which is equals to 7 by 12. So in one step, in one answer we got it as minus 7 by 12. In the other case we got it as just 7 by 12. So subtraction is not commutative for rational numbers. What does it mean? If we change the order of the rational numbers, the answer also changes. Hence commutativity does not hold good for subtraction in rational numbers. Okay. Now let us take commutativity for multiplication. For any two rational numbers, a by b into c by d is equals to c by d into a by b. What it tells us that if we change the order of the multiplication between two numbers, then also the answer will remain the same. Now let us check it in this case. Minus 7 by 3 into 6 by 5. Let us multiply the numerators. It is minus 42. Then let us multiply the denominators. It is 15. So minus 42 by 15 is the answer. Now let us rearrange these rational numbers. That is a by b into c by d. Now we have c by d into a by b. So 6 into minus 7 is 42 divided by 5. 5 in, not divided, it's by 5 into 3 is 15. Therefore, in both the cases, the answer was the same. Hence, multiplication is commutative for rational numbers. Now, let us do the same thing in the case of division. Now, minus 5 by 4 divided by 3 by 7. Now, when I get the symbol division, what we do? We multiply it with the reciprocal. So, minus 5 by 4 into 7 by 3, which is equals to minus 35 by 12. This is the answer we get. Now, let us check it if we change the order. That is 3 by 7 divided by minus 5 by 4. It is 3 by 7 into minus 4 by 5, which is equals to minus 12 by 35. Therefore, when we change the order, the answer also changes. Hence, division is not commutative for rational numbers. So, I hope you understood. In the case of rational numbers, division does not commutative. Okay. Now let us go to the next property, that is associativity. Now under associativity, we will check in the case of addition. That is, I have to add two rational numbers. It is of the form a by b plus c by d plus e by f. Okay. Now let me solve the numbers that are within the brackets. So let me take the LCM. 5 will go in this 6 times, it is 18, plus of minus 6 will go in this 5 times, it is minus 25. So the answer is minus 7 by 30. Now I have minus 2 by 3 minus 7 by 30. So when I take the LCM, it is 30. So minus 2 will go in this 10 times. So it is minus 20. 30 will you get minus 7. It is minus 27 by 30. Okay. Now in the case of when we change the order, that is order means I will first add this both and then add this. So I have done this here. Minus 2 by 3 plus 3 by 5. I added plus minus of 5 by 6 is I have taken the LCM as 15. 15, 3 goes in this 5 times, so it is minus 10 plus 9, to which I have to add minus 5 by 6. So I get minus 10 and plus 9 is minus 1 by 15 minus 5 by 6. Once again I take the LCM, it is 30. I get minus 2 minus 25. When I add it, I get minus 27 by 30, which is minus 9 by 10. This also you can further reduce it as minus 9 by 10. Hence the answer is same in both the cases. So addition is associative for rational numbers. So for any three rational numbers A, B and C, A plus B plus C is equal to A plus B plus C. I hope A can also be written as A by B, C by D and E by F. This also can be, you can also take them as examples of rational numbers. So associativity holds good in the case of addition. Now let us check it in the case of subtraction. For that, let us see the LHS. Now what is the LHS? LHS is nothing but 2 by 3 minus of, let us take the LCM. 5 will go in this 2 times, I get minus 8, and 2 will go in this 5 times, I get minus 5. So the answer is 2 by 3 minus of minus 13 by 10. Okay. Now let us find the LCM of 3 and 10. 3 will go in this 1 time, 2 will go in this 5 times, and I get, what do I get? I get it as 3 2s are 6, 6 5s are 30. So the LCM is 30. So what do I get? 3 goes in this 10 times, so it is 20 minus 10 goes in this 3 times, so it is 39. So I get 59 by 30. Now let me repeat it in the case of the associativity. Let me check it the other way. What is the other way? It is plus 2 by 3 into minus of minus 4 by 5. This thing should be subtracted by half. Okay. So now let us find what is, let us solve whatever it is there in the brackets. 3 goes in this 5 times, 5 2s are 10, 15 goes in this 3 times, it is minus 12. So I get answer as 22. 10 plus 12 is 22 by 15. To that I have to subtract 1 by 2. Now the LCM is, what is the LCM? 15 and 2. 2 will go in this 1 time. Then 3 times it will go 5 times. So the LCM is 2 3 are 6, 6 5 are 30. 15 goes in 32 times, it is 44. 2 goes in this 15. It is minus 15, which is nothing but 9, and 29 by 30. So the answer is different. In this case we got 59, here we have got 29. So subtraction is not associative for rational numbers. Okay. If we change the order of subtraction, the answer also will vary. Okay. Now we will go associativity in the case of multiplication. Let us take two numbers, A by B into C by D into E by F within brackets. Okay. So if we multiply these numbers 2 by 3 into 1 by 4 into 2 by 6, let us solve whatever is there in the brackets. So it is 1 into 2 is 2, 4 into 6 is 24. So I will multiply whatever answer I get with 2 by 3. So I get 4 by 72 or 1 by 18. Similarly, I will change the order. I will multiply this both first and then with that answer I will multiply 2 by 6. So 2 into 1 is 2, 3 into 4 is 12. That into 2 by 6 which is equals to 4 by 72 which is equals to 1 by 18. Therefore, multiplication is associative for rational numbers. That is, for any three rational numbers a by b, c by d and e by f, a by b into c by d into e by f within the brackets is equals to a by b into c by d within brackets into e by f. So if we rearrange the order also, the answer remains the same. Hence, associative property holds good in the case of multiplication. Okay. Now let us check in the case of division. Associativity in the case of division. So first within the brackets let me solve it. So 1 by 3 into 5 by 2. Okay, I have to multiply it, isn't it? So I will multiply it with the inverse. So what do I get? 5 by 6. Now this is nothing but 1 by 2 into 6 by 5 which is equal to it is equal to 6 by 10. Okay. Similarly, let us take this number that is within brackets 1 by 2 into 3 by 1, that is nothing but it is 3 by 2, that into 5 by 2 is equals to 15 by 4. I hope you got it. I first solved these two terms. I got 1 by 2 into 3 by 1 which is equals to 3 by 2 divided by 2 by 5. So it will be multiplied by 5 by 2 which is equals to 15 by 4. So the answers are different. So division is not associative for rational numbers. That is, for any three rational numbers a by b divided by c by d divided by e by f, I get a by b divided by c by d, the answer divided by e by f. Hence, when we change the order of the numbers, the answer also changes. Now we'll go to the next one, that is additive inverse. For for the number 2, the additive inverse is minus 2. You would have learnt in your lower classes. 2 plus of minus 2 is equals to 2 minus 2 which is equal to 0. So what is the number that I should add to 2 so that I get the answer 0? Minus 2. To get, so the additive inverse for 2 is minus 2. Similarly, the additive inverse for 1 by 5 is equals to minus 1 by 5, because when I add 1 by 5 with minus 1 by 5, I get the answer 0. So minus 2 by 3, for minus 2 by 3, the additive inverse is plus 2 by 3. I hope you understood this. What is the number with which I add so that I get the answer 0? So if I add it with if it is 1 by 5, if I add it with minus 1 by 5, I will get the answer as 0. Okay. Now 0 is the identity for the addition of rational numbers. That is, if I add 0 to any rational number, I get back the same number. Okay. So minus 2 by 5 plus 0 is minus 2 by 5. If I change the order also, I will get the same number. So 0 is the identity for the addition of rational numbers. Similarly, 1 is the multiplicative identity for rational numbers. That is, if I multiply any number by 1, I will get back the same number. That is, 3 by 4 into 1 is equals to 3 by 4. Similarly, minus 2 by 7 into 1 is minus 2 by 7. So 1 is the multiplicative identity for rational numbers. Now, consider 3 by 5. Now 3 by 5 into 5 by 3 is equal to 1. We say rational number c by d is the multiplicative inverse of another rational number a by b if a by b into c by d is equal to 1. So in this case we learnt about the multiplicative inverse. That is, if 3 by 5 is a given number, then 5 by 3 is the multiplicative inverse. I hope you understood this. Thank you, friends.